Sure. So the attributes that make a battery more valuable than the ones that came before it are the obvious ones. Energy density, that means you can store a lot of energy in a small package or a lightweight package and therefore get a long runtime for a product. Power density, which is different than energy density. Power density gives you the ability to have a higher powered product in the same size or weight package. Cycle life, how many times can you charge and recharge and charge, discharge, recharge, and so on. And then shelf life. How many years can a battery be installed in something like, say, implantable defibrillator? Maybe it sits there for 20 years and never has to act. But when it's needed instantly, and it has to be at full power. Then some kind of less obvious ones, like, for example, temperature range of operation. Cars now, new cars in the last few years, all have tire pressure monitoring systems to monitor the inflation pressure of the tires. And as anyone who has one of these cars knows, there's often false alarms. And the main reason behind those false alarms is that the batteries that are mounted in the tire, in the wheel, are subject to a very wide range of temperatures, from maybe minus 40 degrees centigrade in the winter in Minnesota to plus 150 in Death Valley in the summer. Really, really hard duty for a battery. And Contour has a chemistry that will withstand that range and farther. So you can even think of such things as building batteries into the tire itself and vulcanizing it into the tire as part of the tire, because the battery is able to withstand the high temperature needed for the vulcanization process. So, as we come up with new battery chemistries, a lot of new products become enabled. Things that you used to have a cord for, used to have rechargeable batteries for, and now you don't have to recharge them. Used to have changeable batteries and you don't have to change them. Or things that you couldn't do at all just because of environmental considerations such as temperature.